This video is on the objective solve linear trigonometric equations in secant or cosecant. Right, one or the other, not both. You're not going to see both functions in the same equation here. Alright, so this is the second one. Hopefully you've watched the first video on this objective and other videos where I've been solving linear trigonometric equations, because they're all done in a very similar fashion, where you isolate the trig function, get the trig function alone on one side, and then think, once around the unit circle going counterclockwise, just think of angles that have that secant or that cosecant or that tangent or whatever function you're looking at. Okay, so if you want to see more about the topic, again, please, click on more instruction, watch their videos, look at their notes, their examples. Hopefully they help you out. Alright, so we're asked to solve the following equation for theta in this interval. Alright, so you're finding all the values I can replace theta with to make this equation true. Now if it has one solution, it's going to have infinitely many, but they don't want all infinitely many solutions to this. They just want the ones that are between 0 and 2 pi. Okay, so I'm going to write this out. So we have -8, right, times the square root of 2 times the cosecant of theta plus 6 equals -10. Alright, so I want to isolate this cosecant of theta, get that alone on its own side. So first I'd subtract 6. So that'll give me the -8 times the square root of 2 times the cosecant of theta equals -16. And then I would divide by this -8 times the square root of 2. So then we'd have the cosecant of theta equals, now a negative divided by a negative will be a positive. 16, 8 goes into 16 twice, so I'd have 2 in the numerator, and then you still have this square root of 2 in the denominator, and 2 divided by the square root of 2 is simply the square root of 2. Okay, so we're looking at this equation. The cosecant of theta is equal to the square root of 2. Now if you don't like working with cosecant, you can do this if you wish. Take the reciprocal. Once you've isolated the trig function like this, you could take the reciprocal of both sides. The reciprocal of cosecant is the sine of theta, and the reciprocal of square root of 2 would be 1 over the square root of 2, which when you rationalize, is the square root of 2 divided by 2. Either way, right, solving this equation on the left is equivalent to solving this equation on the right. They'll have the same solutions. Alright, now just think once. All I like to do here for these is think about going around the unit circle one time. Alright, you can draw your own unit circle if you wish. I'm not going to do that. Alright, just picture it. And think of what angles have a sine of square root of 2 over 2, or equivalently a cosecant of positive square root of 2. Now if these are positive values, that means we're going to be in quadrant 1 and quadrant 2. Right, those are where sine was positive or cosecant was positive. Now the quadrant 1 angle should be easy enough, right? That was 45 degrees or pi over 4 radians. So I'm going to start into writing the general solution, right? I'm going to be describing all infinitely many solutions to this equation. So one of these was pi over 4, right? The cosecant of pi over 4 would be square root of 2. But then I could, take that pi over 4 and add 2 pi, subtract 2 pi, right? I could really add any multiple of 2 pi and get the same result. All right, and this is where k is any integer. But that's not the only one, right? There's also an angle in quadrant 2, drawn in a standard position. It would have the same reference angle, still have a reference angle of pi over 4. So that would be what? 3 pi over 4. right? 135 degrees. That also had a cosecant of square root of 2, or a sine of square root of 2 over 2. And then this 3 pi over 4 angle, I could again add or subtract any multiple of 2 pi to that and get the same result. So I have plus 2 pi k there. Alright, so here's a description of all infinitely many solutions to this equation. And I'll list some. Alright, again, you've seen me do several videos now on these. I like to list a bunch of solutions just to get a feel for them. So I'm going to be listing a bunch of solutions. Now when k is 0, you just have the pi over 4 and the 3 pi over 4, right? Those are solutions. And then when I go to the right here, I'm just going to increase the value of k by 1 every time. And every time I increase the value of k by 1, that's just adding 2 pi, which is the same thing as adding, 8 pi over 4, right? If I get a common denominator. And when I go this way, I'm going to be, if I decrease k by 1, every time I decrease k by 1, it's subtracting 2 pi, right? Or subtracting 8 pi over 4. So pi over 4 is a solution. Add 2 pi, 9 pi over 4, right? Is another solution that's adding 8 pi over 4, 2 pi, right? Then do it again, 17 pi over 4 would be another solution. I could do that forever. Going this way, I'm subtracting 2 pi or subtracting 8 pi over 4. So negative 7 pi over 4 would be another solution. Negative 15 pi over 4 would be another solution, and so on. With this 3 pi over 4, do the same thing. Keep adding 2 pi, you get more solutions. 11 pi over 4 would be another solution. 19 pi over 4 would be another solution. Subtracting 2 pi, subtracting 8 pi over 4. Get negative 5 pi over 4 would be another solution. Negative 13 pi over 4 would be another solution, and so on. So what I've just done here, I've just listed for you 10 solutions to this equation that we started with. But we don't want all 10 of these. I just want the ones from 0 to 2 pi. All right, we only want the solutions that range from 0 to 2 pi. Okay, so what are those? Well, 2 pi, remember, is 8 pi over 4. So all these solutions over here are too big. All these solutions over here are too small. They're less than 0. So the only ones that fit in that range are pi over 4 and 3 pi over 4. So that's all they want. Right? Pi over 4 and 3 pi over 4. And again, select all that apply. So there's multiple solutions here. Great. And again, hopefully watching me do this, looking at the more instruction, looking at the answer explanations when they come up, hopefully all this stuff helps you when you're doing this on your own. And thanks for watching.